So from yesterday on page, let's look at 42. Okay, on page 42, we said we'd start here. Okay, number 2, -1. So we're describing the pattern, writing and drawing or draw the next 2 numbers, letters, or figures. So here we said we add 2, alternate between positive and negative. Okay, and so really we were looking at dealing with prime numbers here. Okay, primes are your right. Primes are the numbers that are divisible by 1 in itself. Okay, so like 1 and 2, 3, 5, 7 is 4 prime. Oh, so this isn't going to work. But what's the next prime? 11, and it will be positive because that one was negative. And the prime after that? 13. Yeah, -13. The next number that is divisible by 1 itself. So those are, so you're listing the next prime number and alternating from positive to negative. Okay. Alternating your positive and negative. All right. On this guy, 2 letters ahead, C. So from C to G. So who did this one yesterday? Who? Carson, you did it? No? Anyone else have the pattern? So when it says 2 letters ahead, I'm not sure exactly what it means. So that means we're just going up by 2 every time? Sam? Skip a letter. So A, B, C, we skip D, there's E. We skip F, there's G. Skip H, there's I. Okay. So you're listing every other letter. Okay, I think that's what they meant by 2 letters ahead. Okay, K, we skip L, there's M, skip N, there's O. Okay? So going up by every other letter. Number 4, adding a line in a box. Some people would say you're adding a square within the square. Okay? So we have 1 big square, and now we have 2 squares. Now we have 3 squares, and then we'd have 4 squares, if you think of it like it's tiles, or 5 squares. Okay? Adding a line in a box, we've got to be a little more specific, probably explaining what that line is, making a square within the box. Okay? Any questions there? A little more clear, I think. Okay, let's take a look at page 43 of your student journal. Compare what you got with your neighbors real quick. So page 43.
I kind of didn't do it. I did it. But...
Okay, let's go ahead and talk about numbers 5 and 6. Okay, make and test a conjecture about the given quantity. So the sum of 2 negative integers. Okay, so the sum of 2 negative integers. What is the sum of 2 negative integers? Is it a negative? How many of you came up with a conjecture? Okay, so it's saying, hey, the sum of 2 negative integers, you got to give an answer. Well, what is that? So some of you are saying it's a negative integer. Okay, that's what I came up with. Very true. And then we test it. We try it out on some. See if we can find a counter example to prove that wrong. Okay. Anytime you add 2 negatives together, you always get a negative. So sum of 2 negative integers is a negative integer. Very good. All right. Let's check out the next one. See if you guys can do it now. The product of 3 consecutive non-zero integers. Come up with a conjecture with your neighbor if you haven't done so already. If you have, anyone have an idea? Drew. It equals a non-zero integer. Okay? Anyone else? KJ? Okay, they'll all be divisible by 3. Anyone else? Yes, honey? Be more than 6 or less than -6. Anyone else? Maddie? What was yours?
I said it had to be an even number, but I don't think that's right.
Had to be an even number. So we have a bunch of different things. So let's try these. Let's test some of these out. 3 consecutive non-zero numbers. Consecutive means goes in order. So let's see if we can rule any of those out. So give me 3 non-consecutive, or consecutive, excuse me.
1, 2, 3.
3, 4, 5. All right. 3 times 4 times 5. A product.
Oh.
Okay.
I added that.
3 times 4 times 5 is 60. Okay, so that breaks the, has to be in between 1 and 6. It is still divisible by 3, and it's even. What was the other one we had? It doesn't equal 0. Okay, yeah.
It has to be the same sign.
Has to be what?
The same sign.
It has to be positive or negative. Okay. All right, so let's test some others out. 1, 2, 3.
6.
6. Okay. So still even, still divisible by 3, still not 0. Okay. The other one we had was
6, 7.
it won't flip signs. So let's go with like -1, -2, -3. Those are consecutive. And that's going to give us -6. Okay. Still even, still non-zero. Okay, all those would work. Yeah, we can't find a counterexample, right? So until we can find a counterexample saying, nope, it doesn't change the sign, or nope, it's not divisible by 3, or nope, it's not even. Yeah. A non-zero integer is any positive or negative, or any whole number, or excuse me, any counting number, 1, 2, 3, 4, 5, 6, 7, 8, and its opposites, the negatives of those. So in other words, no decimal, like no numbers with that are like 1/2 or 1/4. Have to be our counting numbers and their opposites. So 0 does not count as that, right? Okay. All right. So if we count 0 in as an integer, would it work?
No.
No. Okay, because it gives us 0. Yeah. Okay. All right, pretty good. Let's move on to 7. So there are multiple conjectures we come up with and tested. Okay, the counterexample will show the conjecture is false. If n is a rational number, then n squared is always less than n. Can we find a counterexample? First, can I pause real quick? A rational number, because I just assume you know what that is. So Jeremiah, what's a rational number? Focus in right here. Ratio. What's a ratio? Number comparing two numbers, like a score on your assignment, right? Okay, so what do we call that score on your assignment? What type of number? Like a fraction. Yeah, a rational number is any number that can be written as a fraction. Okay? So if n is a rational number, then n squared is always less than n. So if n can be expressed as a fraction, n squared is always less than n. Talk to your neighbors. True or false? Show them your counterexample.
Can you do 9 divided by 3? Is 9 divided by 3 a rational number?
Yeah, 9/3.
Yeah, that works.
Okay.
It's false.
So, is n squared always less than n?
No.
So give me a counterexample. Cynthia. Okay, if n is 10 over 8, which n squared then would be? So n squared would be 100 over 64. Yeah? Okay. So does that work? Okay. So what is 10 divided by 8? 1.25. Okay, 1.25. And what is 100 divided by 64? All right. Therefore, that's a counterexample. N squared is bigger than n. Okay, good. line K intersects plane P at Q, and plane P is perpendicular to line K. Show your neighbor what you put as a counterexample.
I just wrote two. I didn't understand how to do this one as a counterexample, but
I think it's true. Perpendicular is like.
it's like if it intersects
It is
at parallel, so draw.
Okay, I want everyone to think of their piece of paper in front of them as plane P. And your pencil or pen as line K. Is there any way for you to make that pen hit that plane? So let me just flip my paper over. Is there any way for me to make my pen hit this plane in a way that is not perpendicular to the plane? Like right now, I'm making it try to be a right angle when it hits. Okay? You could change the angle of it, right? Okay? That would be a counterexample. So if you're trying to draw that, I mean, here's point Q, where it hits. Your pen can hit at an angle. Or your line can. We're calling it line K. Okay, and it comes down like so and goes through. Okay, and to really show that, you could express, hey, that's a 30-degree angle. Okay, it's really hard for you guys to see. Zoom back in there. All right, we're going to go through the law of detachment and the law of detachment here in a minute. Just to make it a little more clear, and the same thing down here. So I'm not going to go into these right now, but I promise you the information I show you will clear it up. Okay? All right. Very good. And then if you have questions on it, you can still ask me. All right. So again, how many know how to get to my website? How many use the website? Okay. So yesterday I had some students that were confused about this. They were asking questions. So I went and tried to find a video that I thought was doing a much better explanation that people could watch from home. And I know that some people did, some people didn't. Some of you had no idea it's there. But I am going to show it right now just so that you recognize when you get home, there are all these other resources available to you. And we're in 2.2 right now. When you go here, notice I have our yesterday's lesson. I'll put today's lesson in there, but then I attach something else with laws of detachment. Okay? All right. So, hopefully, let's see if I can get the sound up on this.
Cool.
We will skip the ad. Oh, yes.
To the math office. Today we are going to talk about.
Now, I'm not saying this guy's amazing. I don't hang with him, but he's pretty good at explaining it.
Let's look at the law of detachment first. The law of detachment basically says that if you have a conditional statement that's true and a hypothesis that's true, then the conclusion is also true. Now, your conditional statement is going to be a general statement, not referring to anyone or anything in particular, usually. Your hypothesis is going to be more specific. Let's take a look at what I mean. Here we have a conditional statement on the board. If you run every day, then you get good exercise. Now notice this is just a general statement. When I say you, I could be referring to anyone, basically. Now we have a more specific hypothesis to go along with that. Emilio runs every day. So what can we conclude about Emilio if he likes to run every day? The answer is Emilio gets good exercise. Let's look at those two statements again. If you run every day, then you get good exercise. Now Emilio runs every day, so Emilio gets good exercise. That's what.
Okay, everyone understand that? It seems extremely obvious, right? Okay, which, yeah, sometimes what we're doing is obvious, but okay, that's what it's saying. So we keep going there.
By the law of detachment. So that's a quick example of how to use the law of detachment. Now let's take a look at how to use the law of syllogism. The law of syllogism says that if you have two conditional statements and the conclusion of one is the same as the hypothesis of the other, then you can conclude that the hypothesis of the first one implies the conclusion of the second one. I know that's a mouthful, so let's take a look at an example that will hopefully clarify this. Here are two conditional statements on the board. If you live in Cleveland, then you live in Ohio. If you live in Ohio, then you live in the Buckeye State. So we can use the law of syllogism to take these two conditional statements and simplify them into one conditional statement. Let's take a look at these two again. Notice that the conclusion of our first statement is the same as the hypothesis of the second statement. They both share the same phrase. You live in Ohio. What we can do is we can remove the conclusion of the first statement and the hypothesis of the second statement, since they both say you live in Ohio. And then the two parts we have left over, we can combine into one conditional statement. This is our conclusion based on the law of syllogism. So if you live in Cleveland, then you live in Ohio. And if you live in Ohio, then you live in the Buckeye State. We can simplify this in our conclusion by the law of syllogism, is that if you live in Cleveland, then you live in the Buckeye State. So that is a quick example of how to use the law of syllogism. Now let's take a look at one more case where you can use both the law of detachment and the law of syllogism at the same time.
Okay, everyone get that? Okay. Now we're going to put the two together here. I'll try to pause and help you out a bit. But
We're going to have one more example up here on the board, and we're going to use both the law of syllogism and the law of detachment to reach a conclusion. We're going to have two conditional statements and a hypothesis. So let's look at these. If you play football, then you play a sport. If you play a sport, then you're an athlete. Tony plays football.
okay, I want you to talk to your neighbor real quick. Oops, let me see if I can get back to the statements there. Come up with what you can use there. Okay?
I'm gonna say, if you play football,
Tony plays football. So let's see what conclusion we can reach when we use the law of detachment and the law of syllogism. We're going to use the law of syllogism first. Let's look at our two conditional statements. Now notice that the conclusion of our first statement is the same as the hypothesis of the second statement. So as we saw earlier, we could remove these two parts, and then what's left we can combine into one conditional statement. So we can remove you play a sport from both statements and say, if you play football, then you're an athlete. So now let's take a look at what we have left. Now we're down to one conditional statement and one hypothesis. If you play football, you're an athlete. Tony plays football. So at this point, we can use the law of detachment to make a conclusion about Tony, since we only have one conditional statement and a hypothesis. Let's take a look. Our conclusion will be that Tony is an athlete. Since Tony plays football, we can conclude by the law of detachment that Tony is an athlete. So there's an example of where you're going to use both the law of syllogism and the law of detachment.
Okay. How many think you got it? Okay, let me try something here and see if we can get this worked out. Okay? Just really quick. All right. If you play football, then you play a sport. And if you play a sport, then you're an athlete. Tony plays football. Okay? So we watched his example there. Let's pretend for a minute that you were not given this piece right here. That middle part. Okay? If you play football, then you play a sport. Tony plays football. Tell your neighbor what you could conclude using the law of detachment. Okay, what could we conclude?
Tony plays.
Yeah.
Tony plays a sport.
Tony plays a sport. Okay? But then when we put that other statement in there, we apply the other law. Okay? If you play football, then you play a sport. And if you play a sport, then you're an athlete. So you just get rid of those. If you play a sport, then you or if you play football, then you're an athlete. We now go the other route. We say Tony plays football, so Tony is an athlete. Make a little more sense? Did that answer some of your questions? Yeah.
Wouldn't number 6 in the homework just be law of syllogism? Because it doesn't say.
Number 6 on which? Yesterday's? I borrow that. All right. So number 6. So if you play baseball, then you play a sport. And if you play a sport, then you are an athlete. So you play baseball, so you are an athlete. So if you play baseball, then you are a sport, or then you play a sport. That's almost like we had on the video here. Okay. So from this, can I write on here? Okay. From this, okay, if you play baseball, then you play a sport. If you play a sport, then you're an athlete. You could say if you play baseball, you are an athlete. Okay? And so that right there is giving the law of what? Yeah?
Well, it's giving a lot of syllogism, but I was going to say, I didn't put detachment, but it's saying you play baseball, and that's the conclusion that you are an athlete, so wouldn't that be the detachment one?
Because you're, so say that again?
So it says you play baseball, and so you can use a lot of detachment to get to conclusion. So, in the video how we use both.
So, yeah. So you're saying it's both because of that. Is that? Yeah. So I understand where you're going with that. So we actually said on this one it was letter C. Okay.
It looks like an O.
Where is that? Do we actually have that? Oh, letter C. We're saying both on it. Okay. You guys, let me write this up so I don't tear apart your paper. Okay? Because I prefer not to write all your. I'll write it on the board here and kind of go through it with us, okay? That'll make it a little easier because then I can erase it. So let me do that. And while I'm doing that, I'm going to give you your assignment and we'll go through. Okay. Hey, here it is, real quick. It shouldn't take too long, so just pause from your assignment, all right? So, if you play baseball, then you play a sport. So this was number 6 on our assignment. If you play a sport, then you are an athlete. Okay, notice I left the last part off there where it says, so you are an athlete. Okay, you play baseball. So right now, just based on just this part, without the you play baseball, you can apply the law of syllogism, right? Where we go, if you play baseball, then you are an athlete. You take the part that is the same and just completely get rid of it. If you play baseball, then you are an athlete. You play baseball. So we applied the law of syllogism here. Now we're applying the law of detachment. You play baseball, so you are an athlete. There's the law of detachment. Okay? I think that's what you're saying, Carlo. Because they give you that piece. Is that what? I think that's what you're saying. I don't know, but okay. So this is both. You're applying both there, getting this statement.
So if you play baseball, then you are an athlete. It just means law of syllogism, and then
The law of detachment's right here. Yep. Very good. So law of syllogism, law of detachment. Okay. Yep. Very good discussion.